any polynomial of degree n is exactly equal to its Taylor polynomial at a, and at every value, right? And so if you have the function f, right, which is a polynomial of degree n at x, then we have the remainder of the Taylor polynomial at x is going to be the n+1 derivative at some point c between a and x divided by n+1 factorial times x minus a to the n+1, right? But now the n+1 derivative of any polynomial of degree n is going to be 0, right? So this is equal to 0. The remainder, the difference between this f and Pna is going to be equal to 0, which is the same f is equal to Pna, which is the same as saying that Pn is equal to Pna. Okay? Now what's interesting about this is that we can now write every polynomial that we want in terms of in the powers of other, instead of powers of x, we can write it in powers of x minus a. Okay, so let me see with an example. We have this polynomial, which is 1 minus 2x squared plus x cubed, and we want to write it in terms of x minus 1. So we have a plus and then b times x minus 1 plus c times x minus 1 squared plus d times x minus 1 cubed. How can we do this? Well, one way to do it is just divide this by x minus 1, right? Over and over, and then you get the coefficient for this. But with Taylor's polynomial, it's easier because you need to compute the Taylor polynomial at 1, right? Evaluate it, so we can compute Pn1 of x is just p at 1, right? And then we have plus p prime at 1 divided by 1 times x minus 1 plus the second derivative at 1 divided by 2 times x minus 1 squared plus the third derivative at 1 divided by 6, which is 3 factorial times x minus 1 cubed, right? Now we can find easily these derivatives because differentiating polynomial is super easy. So this is just minus 4x plus 3x squared evaluated at 1. So this is minus 1, right? Now we have the second derivative at 1 is minus 4 plus 6x evaluated at 1, which is 2. And the third derivative at 1 is going to be 6, okay, everywhere. And then we have p at 1, sorry, which is 1 minus 2 plus 1, 0, right? And then with this, we can get Pn1 at x is just 0 plus minus 1 times x minus 1 plus 2 divided by 2, so 1 plus x minus 1 squared, and then plus 6 divided by 6, which is x minus 1 cubed. Okay, and so this is the Taylor polynomial at one of this polynomial, but we know it's exactly the same, so we can write it like this. We can say that this is just p of x, right? And if you expand these things and simplify, you will get back to the original polynomial. But this is useful in some cases, and so you would do well to remember. Okay, that's it for now.